Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. Welcome to our comprehensive exploration of building a thinking machine using the Novamente AI engine. We'll journey to the fascinating world of artificial general intelligence, examining how Ben Goertzel's revolutionary Novamente system attempts to create genuine machine intelligence through infant-inspired cognitive architectures. This video will guide you through the theoretical foundations, practical implementation steps, and future implications of this groundbreaking approach to AGI. Novamente's architectural philosophy is fundamentally integrative. It synthesizes aspects from diverse AI paradigms, including symbolic logic, neural networks, evolutionary programming, and reinforcement learning. This hybrid approach draws heavily on system-theoretic ideas, aiming to model complex mental dynamics and the emergent patterns that characterize intelligence. While not a direct simulation of the human brain, Novamente's design is closely inspired by high-level human cognition, with its learning, reasoning, and perceptual mechanisms loosely informed by human psychology and neuroscience. The overarching goal is to augment human intelligence and capacity rather than to supersede it. The Novamente AI engine, initially a proprietary system known as the Novamente Cognition Engine or NC, has evolved significantly. In 2008, parts of its code base were open source, giving rise to OpenCog. OpenCog was designed as a flexible, generic AGI platform and framework upon which specific cognitive architectures like OpenCog Prime could be built. The latest and most advanced iteration is OpenCog Hyperon, a new, mostly from the ground-up redesign. Hyperon boasts an almost entirely new codebase, focusing on radical scalability and leveraging new mathematical approaches. It introduces the meta-programming language as its core and is designed for distributed computing, including blockchain integration, with the ultimate ambition of achieving human-level AGI and progressing towards artificial superintelligence. At the heart of Novamente lies the SMEPH framework, a mathematical and conceptual foundation that enables true machine intelligence. Self-modification allows the system to improve its own algorithms based on experience. Evolution ensures continuous adaptation to new challenges. Probabilistic reasoning handles uncertainty and partial information, much like human cognition. Hypergraphs provide a rich representational framework that goes beyond simple neural networks, allowing complex relationships between concepts, procedures, and goals to be represented and manipulated dynamically. The atom space is the foundational knowledge representation component of Novamente and OpenCog. It functions as an in-rhyme generalized hypergraph database, storing knowledge as atoms, weighted, labeled nodes, links, and containers. These atoms are designed to represent virtually any kind of domain knowledge, from classical predicate logic and natural language to Bayesian probability networks and neural network structures. While atoms themselves are immutable and uniquely identified, values can be dynamically attached to them to represent transient data like truth values or probabilities. A powerful pattern matcher serves as a query engine, enabling efficient search and discovery. Probabilistic term logic, or PTL, is Novamente's robust framework for reasoning under uncertainty. It's designed to be highly flexible, accommodating dynamic and mixed-type data. PTL employs multivariable truth values, where each piece of knowledge is associated with both a probability and a weight of evidence, reflecting the system's confidence. Inferences are context-aware, adapting to the scope of available information. PTL incorporates a rich set of inference rules, including deduction, induction, abduction, and Bayesian inversion, alongside mechanisms for analogical reasoning and knowledge revision. Its core objective is to provide accurate and scalable probabilistic inference that integrates seamlessly with both term and predicate logic, a critical capability for a generally intelligent system operating in the real, uncertain world. The Bayesian optimization algorithm, or BOA, is a cornerstone of Novamente's learning and discovery capabilities. It extends traditional genetic algorithms by evolving programs written in sloppy combinatory logic, enabling the system to learn and refine its own complex procedures. BOA is instrumental in pattern mining, identifying novel and significant patterns within large datasets, which then leads to the creation of new predicates and cognitive schemata. This process also contributes to concept creation and the development of hierarchical cognitive structures, including a mechanism called slippage for intelligent concept substitution. With the advent of OpenCog Hyperon, the meta-language, or metatype talk, emerges as a pivotal innovation. Meta is a novel programming language specifically crafted for AGI, integrating elements of functional, logical, and probabilistic programming. Its unique design allows meta-programs to be represented as subgraphs within the atom space, enabling them to directly query and rewrite portions of the knowledge base. Meta also facilitates robust neural-symbolic integration, and its non-deterministic interpreter functions as a powerful inference engine, making it the firmware and glue that holds Hyperon's diverse components together. Practically implementing a Novamente-powered AGI involves several key steps. First, establishing the atom space as the flexible knowledge hypergraph is paramount, serving as the unified data store. Around this, various AI agents, or mind agents, are implemented, each carrying out specific learning, reasoning, or perceptual algorithms. With OpenCog Hyperon, the meta-language becomes central for scripting cognitive processes and enabling the crucial self-modification capabilities. The system is designed with a plug-in architecture to ensure seamless interaction between cognitive, perceptual, and control algorithms. For large-scale AGI, leveraging OpenCog Hyperon's distributed computing and blockchain integration capabilities is essential for scalability. The journey to building a thinking machine with a Novamente AI engine, now manifest in OpenCog Hyperon, represents a profound scientific and engineering endeavor. Its integrative architecture, combining diverse AI paradigms, and its emphasis on continuous learning and self-modification, offer a promising blueprint for achieving artificial general intelligence. The shift towards an open-source ecosystem is poised to accelerate this progress through collaborative innovation. However, realizing the AGI dream demands an unwavering commitment to ethical development, ensuring these powerful systems are aligned with human values and augment our capabilities. The creation of true AGI has the potential to radically transform the human race, ushering in an era of unprecedented intelligence and capability. I am now happy to take any questions and comments. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.